In this video, we're going to focus on writing transformations for exponential and logarithmic functions. Now, before we jump in and write exponential and logarithmic transformations, let's make sure we remember our transformation basics. So, for the sake of this video, I changed the bases for each exponential and logarithm to be a capital B, because I didn't want you to get confused. B does stand for base here, but it also stands for a type of transformation. So just note that the B values here that are capital B's in each stand for the base of those two functions. So the base of the exponent and the base of the logarithm. Now remember, your A value is going to be your vertical stretch, shrink, and flip. And your A value will be a multiplication to the Y values, or a multiplication on the outside of the function. Then we have our B value, which is our horizontal stretch, shrink, and flip. And this one is going to happen on the inside of the function, and it's again going to be multiplication. We can see x gets multiplied by b, and remember that this one deals with the reciprocal. So if we're told that we have a stretch of 2, we're going to flip it to its reciprocal of 1 over 2. So remember, this uses the reciprocal, so we have a flipped fraction here. Then next we have our k value, which is a vertical translation. So it's going to make the graph move up and down. So we have vertical translation. We move up and down when we perform our k value, and it's going to be an addition or subtraction on the outside. And it works just as expected. So if we're going to move up 3, we add 3 to the outside. Then finally, h is our horizontal translation, and it's going to move the graph left and right, and it's always going to work the opposite of what we expected. So if we think we're going to move to the right 4, it's going to be a subtraction of 4. So just remember, it works the opposite. So we have to pick the opposite sign of the way that we want to move. Now, knowing all of this information is going to help us as we write our own transformations. We have a couple more notes we're going to take here. The first thing that we want to note is that if we have anything that is a vertical change, so whether that is a vertical stretch, shrink, or flip, or it's a vertical translation, moving the graph up or down, these all happen on the outside. So these are going to happen on the outside of the function. If we have a stretch, shrink, or flip, we're going to be multiplying on the outside. If we have a translation, we're going to be adding on the outside. The other thing we need to remember is that if we have any sort of horizontal change, so if you see a horizontal change, this is going to happen on the inside, and it's going to specifically happen to x itself. So we're either happening way on the outside, or we're going very, very close on the inside, just applying this change to x. And if something is on the inside, so a stretch, shrink, or flip, or a translation left or right, it then also applies just like the vertical ones. If it's a stretch, shrink, or flip, we're going to multiply on the inside. If it is a translation moving left and right, we're going to add on the inside. Now, the last detail to remember here are that these horizontal ones kind of work the opposite of what we expect. So if it's a stretch, shrink, or flip, yes, we're going to multiply, but remember, we multiply by the reciprocal. So if we're told that we have, a stretch of 2, we're going to flip it over to 1/2. Or if we have a shrink by 1/3, we're going to flip it over to 3/1. So when we do the stretch, shrink, or flip, we have our reciprocal that we utilize instead. And then remember, if we're moving left and right, it works the opposite of what we expect. So if we're moving to the right, it's going to be going in the positive direction, so we're going to subtract. If we're moving to the left, it's going to be moving in the negative direction, so we're going to add. So if we take a look at the example here, we can see that we have a logarithm of base 5 with some transformations already applied to it. And what we're going to do is we're going to apply each of the transformations on the left-hand side, and we're going to apply those transformations to the function that we currently have. So let's start off with this reflection over the y-axis. Now remember, if we're reflecting over the y-axis, we're doing a reflection here. Because that is a horizontal reflection, we know that this is going to happen inside. And because we have a reflection, it's going to be a multiplication of -1. So essentially what's going to happen is we're going to multiply the inside, which is the x value, by -1. So we're just going to multiply x on the inside by -1. So if we do that, we end up with g of x is the name of our new function. So we have g of x is equal to 3 times log base 5 of -1x minus 5 plus 4. So notice that when it's happening on the inside, it only happens to x itself because it's going to the most inside part and we're multiplying x by -1. Then the next thing we're going to do is we're going to vertically stretch the graph by a factor of 3. And remember, a vertical stretch is our a value, and it's a multiplication of 3 on the outside. So we're going to take this entire function and we're going to multiply it by 3 on the outside. This means that the coefficient of our log gets multiplied by 3, and the 4 over here gets multiplied by 3. Each term, or each set of items, so this is one term because they're all grouped together, and that's a second term, gets multiplied by 3. So g of x now looks like 9 times log base 5. Then we have -1x minus 5 plus 12. So notice the coefficient of the log and the number on the outside. Each term, that first number gets multiplied by 3. Now, this last one here is the trickiest one, I think, of all of the translations. And this is a horizontal translation 4 units to the right. So translations, we know, deal with the h value. So they're going to go on the inside with x. We also know that if it's going to the right, that's the positive direction. So we're going to be subtracting 4. Now the trickiest part of this whole process is this is really going to happen to just x. So we're going to put little parentheses around x, and we're going to put that -4 on the inside of the parentheses with x. So notice it's not just being combined with the -5, but instead, if you'll look carefully, what I'm doing is I'm saying, well, I have -1, and then I have x, and with x I have x minus 4. So I really sneak x in there to just happen to x. And then from inside of there, once x is being applied, or once -4 is being applied to x, now you'll see, well, I have a little bit of extra work to do. So when you apply a translation or anything that is horizontal, it's going to just happen to x itself. Then you have to apply any distributions that you also see. So here we're going to do x minus 4 inside with parentheses. So look carefully how I added those parentheses in. I then need to distribute this coefficient that was in front of x, so that's -1. Both the x and the -4 have the -1 applied to it. So inside of this parentheses here, I'm really getting -1x plus 4 minus 5. So this becomes -1x minus 1. So notice the slight difference there. We added in those parentheses around x and we subtracted 4 from x specifically and then applied that coefficient and simplified the expression a little bit further. So here we now have g of x is equal to 9 times the log base 5 of, in parentheses, -1x minus 1, and then on the outside a positive 12. So this is our new function with all 3 of these transformations applied. So now let's take a look at an exponential example. So I notice that this exponent has a base of 5. So that's just the base of my exponent. The other numbers represent some combination of the current values of a, b, h, and k. So we're going to apply three transformations here. The first one we're going to apply is a reflection over the x-axis. So I know here's my x-axis, and a reflection over that would be a vertical reflection. So I'm going to multiply the outside by -1. So what I'm going to end up doing is I'm going to multiply the coefficient here of my exponent by -1, and then this term by itself by -1. So I'm multiplying each chunk by -1. So my new function down here is going to be g of x is equal to a positive 2 times 5 to the power of 4x plus 2, and then plus 1 on the outside. So then from here, we're going to vertically translate it down 3 units. So because it's a vertical translation, I know I'm going to be applying this to the outside. And we're going to subtract 3 units outside. So if I subtract 3 units here, I end up with g of x is equal to 2 times 5 to the power of 4x plus 2 minus 2. Then the last thing here is we're going to horizontally stretch the graph by a factor of 1/2. So that means we're going to multiply by, remember this flips to its reciprocal, so we're going to multiply by 2/1 on the inside applied to x. So we're going to multiply this by 2. So our final function here becomes g of x is equal to 2 times 5 to the power of 8x plus 2, all minus 2.